So guys, in the next two classes we are going to just solve some problems, and problems will be solved in terms of assignments also. Okay, so this will increase the understanding, I hope so. So the first problem which we are going to solve is this one: find the even and odd components of x of t, that is equal to e power jt. This is the question. The requirement is we have to find the even and odd components of this particular signal. Remember, we can uh, dissolve any given signal into even as well as odd signal. So let's write the even signals formula. X e of t is equal to half times of x of t plus x of minus t, right? What is x of t? E power jt, right? So it's x of et can be written as half times e power jt plus e power minus jt. Similarly, xo of t, that is nothing but odd component, right? Odd components formula is half times x of t minus x of minus t, right? So this can be written as half into e power jt minus e power minus jt. This is nothing but, I hope you remember this particular formula as well as this particular formula. What is that? I give you some seconds of time. Look, online class is bit tough actually. I really want you to check your no, actually your knowledge about this particular subject, but I cannot able to do it now. However, this particular formula, I hope you remember this. Half times e power jt plus e power minus jt is nothing but cos of t. Cos of t. So this means half of e power jt minus e power minus jt is nothing but let me rub this. So this is going to be as per formula. Okay, I have not done anything extraordinary. J into sin t. So as per this question, I have found out the even part as well as the odd part. That means even component as well as the odd component. So let's try to solve some other problem on this. So the next question is going to be x of t is equal to sin of t. So we have to check whether this is a even signal or odd signal. So what is the condition to check? X of t is equal to x of minus t. This is I am going to call it as even signal, right? And x of t is equal to minus x of minus t. This particular signal I am going to call it as odd signal, right? So these are the two basic, sorry for that. So these are the two basic conditions to check whether which particular signal this particular signal belongs to. Let's check. x of t is equal to sine of t. So sine of t la namal minus சேர்த்து நோക്കാം. Sine of minus t is equal to minus sine of t. Am I right? Okay, so what happens to the original signal? So original signal I can write like x of t is equal to minus of x of minus t. So this particular condition, that means the second condition, prevails. So I can honestly call that the given condition, given particular signal, this one is nothing but an odd signal. So like this, in your exam they may ask you, by giving some signal, they may ask you whether the given signal is a even signal or odd signal. Okay, let's see third example. Okay, this is the origin. We are going to check whether this particular signal is even or odd. Okay, so if we are in the class, I would have asked you to do it online class, so I am forced to do myself. So for checking this particular condition, we have this equation x of t is equal to x of minus t. If this prevails, we call it as even signal, right? So what will happen if I invert this one? Mirror. I mean, x of minus t, this particular thing is nothing but a mirroring, right? So even if I mirror it, the time duration has been not given in the question, so we can assume this is minus 1 as well as, no, this is plus 1 as well as this is minus 1. So even if we mirror it, we are going to get the original signal back. So this is going to be minus 1, this is going to be plus 1, and hence, since this particular condition has been proven true, we call this given condition as even signal. Okay, so let's solve one more example. So this is the given signal x of t. So here you have been asked to find whether this particular signal is odd signal or even signal. So the condition you know, let's try to inverse it. The condition you know, you have to check your notes. Okay, in case if you are inversing this particular signal, that is, if you are trying to invert it, what we are going to get is an x of minus t, right? So x of minus t is going to be this one. Alright, this is going to be the inverted signal of the original signal. So that means x of t is not going to be x of minus t. So that definitely this is not going to be an even signal. This is not going to be an even signal. However, let's check whether this is an odd signal. Okay, even signal illa namakku manasilai adu karyam manasilai, പക്ഷേ odd signal ആണോ നമ്മൾ നോക്കുമോളെ. Let us see that. Odd signal condition നിങ്ങൾക്ക് അറിയാം, x of t should be equal to x of minus t അല്ലേ. അപ്പോൾ ഇതാണ് x of minus t. അപ്പോൾ minus of x of minus t, what is that? This inversion is there. So amplitude inversion. So minus of x of minus t, I am going to draw it here. This is going to yield me again the same signal. So this means the given signal is nothing but an odd signal. Okay, so let's try to solve one more problem on this. x of t, simple problem, okay? X of t is equal to t. X of t is equal to t means, in case if we can draw this, it is going to be like this. Okay, this, I mean, x-axis is going to be the time domain, and this is going to be x, and totally we can call it as x of t, right? This, in case if we can extend it, going to be falling like that. Okay, x of t is equal to now the question is, we have to check it whether this is an even or odd signal. Okay, so how to check that? The condition is x of t should be is equal to x of minus t, minus of x of t should be an odd signal, or else x of t should be is equal to x of minus t. This is for even signal. So let us try to time inverse this particular signal. So what will be the resultant output? This is going to yield me something like this, right? This is x and this is t. So in order to get back the original signal, what I have to do is I have to time inverse it. Sorry, in fact, we have to amplitude inverse it, right? So what I'm trying to say is, to get back the original signal, I should follow this particular condition. X of t is equal to x of minus t. Am I right? But in this case, this is wrong. But having said that, this is correct, right? So this is nothing but, this particular signal is nothing but x of minus t. So in order to get back the original signal, all I have to do is I have to ulta it, right? So when I am trying to invert this particular signal, I will get back the original signal. So that is nothing but minus x of minus t, right? So this particular given signal is nothing but an odd signal. In case if you have a doubt, even before jumping the guns, okay, even before asking me, please check out the equation, please draw it, think about it, okay, because we are an engineers, we should grow about it. Okay, now the next signal I am going to introduce is this one. Oh my goodness, oh, 1 minute, let me draw that one more time. This one, okay, like this. Okay, so this particular signal, mathematically if you write it, it is going to be x of t is equal to t square. This is t square. Okay, if I can draw this particular, this is the signal which I am going to get, right? So whether the given signal is odd or even, that's the question. Okay, so just by seeing this particular signal, even if I am inverting this part to here, or this part to here, whatever the way I am going to get back the original signal back, right? So whatever the way I am going to draw this, I am going to get back the original signal. Hence I can conclude that x of t is equal to x of minus t. So the given signal is nothing but an even signal. Okay, so the next question which I am going to explain is this one. Let me write that. Show that the product of two even signals or of two odd signals is an even signal. Okay, show that the product of two even signals, that means what, I don't know meaning in that, two product of sorry, the product of two even signals is an even signal, or of two odd signals, product of two odd signals is an even signal, right? And our question order stop avunalla, and product of an even signal and odd signal is again an odd signal. Please write this question, extremely important, man. This particular question has been asked for the university exam. Please write it. I'm going to repeat. Okay, I'm trying my best to improve my handwriting, but this is what I can do. Okay, pen tab. This is the first time I'm using online classes, etc. I have told you already. So first time I'm using. I'm trying to improve myself, but this is what I could able to get. So let me solve that. Y of t is equal to y1 of t into y2 of t. An assumption, okay? If y1 of t and y2 of t both are even, then what does it mean? Y of minus t is equal to y1 of minus t into y2 of minus t. Am I right? So that means, according to the definition, y1 of t into y2 of t, this is nothing but again y of t, and y of t is even, right? If y1 of t and y2 of t are odd, then y of minus t is equal to y1 of minus t into y2 of minus t. This I can write like y minus y1 of t. I am writing it here, okay? Minus y2 of t so this means y1 of t into y2 of t, that is nothing but y of t, okay, and y of t is even. Am I right? So if y1 of t is even, look, I am just solving the question, okay? If y1 of t is even and y2 of t is odd, then how I can write this particular question? Y of minus t is equal to y1 of minus t into y2 of minus t. This is nothing but y1 of t minus of y2 of t. This I can write like minus y1 of t into y2 of t is equal to minus y of t. And hence I can conclude that y of t is odd, okay, because of the execution. Note that we have done the analysis, right? Note that in the above analysis, this particular t, the variable t represents the time in continuous domain, okay? That means analog domain. However, for the exam, they may ask you the same question because it's very, very important. The same question can be asked for the discrete domain also. Same time of proof exists there also. Okay, so you can work out that. I leave it as a homework. One more question we are going to solve this. This is going to be the last question. അതായത് കുറച്ച് ഇമ്പോർട്ടൻറ്റ് ക്വസ്റ്റ്യൻ ആണ്, ശ്രദ്ധിക്കുക. If x1 of t and x2 of t be periodic signals with fundamental periods of t1 and t2 respectively. That means x1 of t in the period t1, this is x2, sorry, x2 of t in the period t2. Okay, this is a question, under what conditions is the sum x of t is equal to, I am writing it here, no space there, x of t is equal to x1 of t is equal to x2 of t is periodic, and what is the fundamental period of x of t if the given signal is really periodic. It's an interesting question. I'll repeat the question one more time. Let x1 of t and x2 of t be periodic signals. That means the x1 of t periodic signal ആണ്, x2 of t periodic signal ആണ്, with the fundamental period t1 and t2. That means in the x1 of t in the period t1 ആണ്, x2 of t in the period t2 ആണ്. Under what condition is the summation ആണ്, product അല്ല. Under what conditions is the sum x1 of t plus x2 of t should be equal to x of t, and both should be periodic. അല്ലേ? അപ്പോൾ x1 of t യും പീരിയോഡിക് ആണ്, x2 of t യും പീരിയോഡിക് ആണ്. രണ്ടും ആഡ് ചെയ്യുമ്പോൾ ഏത് കണ്ടീഷനിൽ ആഡ് ചെയ്യുമ്പോൾ ഇത് അഡിഷൻ്റെ വാല്യൂ ഉണ്ടല്ലോ, അഡിഷൻ്റെ വാല്യൂ പീരിയോഡിക് ആയിട്ട് മാറും. Under what conditions is sum of x of t is equal to x1 of t x1 of t plus x2 of t is periodic, and what is the addition ചെയ്ത ശേഷം, okay, and what is the fundamental period of x of t if it is periodic. അപ്പോൾ periodic ആയാൽ മാത്രം fundamental period ചോദിച്ചാൽ മതി. Okay, ഇതാണ് question. Let me solve this. Since x1 of t യും x2t of t യും പീരിയോഡിക് ആണ് അല്ലേ, അതാണ് ക്വസ്റ്റ്യൻ. പക്ഷേ ഫണ്ടമെന്റൽ പീരിയഡ് എന്താ, റെസ്പെക്റ്റീവ്ലി T1 and T2 ആണ്. അപ്പോൾ ഇതിൻ്റെ ഫണ്ടമെൻ്റൽ പീരിയഡ് T1 ഉം ഇതിൻ്റെ ഫണ്ടമെൻ്റൽ പീരിയഡ് T2 അല്ലേ? അപ്പോൾ let me solve this. x1 of t according to the definition this should be written like this: x1 of t plus t1 is equal to what will be that? x1 of t periodic signal ന്റെ definition ആണിത്. ഇതിൽ m is an positive integer. ഇത് പീരിയോഡിക് സിഗ്നലിൻ്റെ ഡെഫിനിഷൻ ആണ്. അപ്പോൾ x2 of t is equal to x2 of t plus t2. This is equal to x2 of t plus ഇവിടെ m ആണ് ഇട്ടിരിക്കുന്നത് അല്ലേ? അപ്പോൾ ഇവിടെ വേറെ ഏതെങ്കിലും വേരിയബിൾ വയ്ക്കാം, k വയ്ക്കാം, k into t2. Again k is an positive integer അല്ലേ? So in order for x of t to be periodic with the period t, we need this particular condition: x of t plus capital T is equal to x1 of t plus capital T plus x2 of t plus capital T. This is the condition for a signal, additional signal to be periodic. Okay, about that means I can write this particular signal as x1 of t plus mt1 as per the definition, okay, plus x2 of t plus k into t2, and again this can be written as m into t1 is equal to k into t2. K into, this is t2, k into t2, and this should be equal to capital T. Let me write in the previous slide എഴുതാൻ സ്പേസ് ഇല്ലാത്തതുകൊണ്ട് ഇവിടെ എഴുതാൻ പോവാം. ഓക്കെ അല്ലേ? അപ്പോൾ പ്രീവിയസ് നമ്മൾ നോക്കിയ ആ ഈക്വേഷനിൽ നമുക്ക് മനസ്സിലാക്കാൻ പറ്റും, ബിക്കോസ് ഇറ്റ്സ് എ പീരിയോഡിക് സിഗ്നൽ. ഓക്കെ, സോ സിൻസ് ഇറ്റ്സ് എ പീരിയോഡിക് സിഗ്നൽ, since it's a periodic signal, നമുക്കറിയാം ആ പ്രോപ്പർട്ടി അനുസരിച്ച് m into t1 is equal to k into t2, and this should be equal to the period, total period. So that means t1 by t2 is equal to k by m. t1 by t2 is equal to k by m, and this should be a rational number. So from the question, what I observe is the sum of two periodic signals is periodic only if the ratio of their respective periods can be expressed as a rational number, as I have explained this. Okay. So the fundamental period for this kind of signals will be LCM of T1 and T2. എടാ ഈ റിസൾട്ട് എന്ന് പറയുന്നത് വലിയതാണ്. കാരണം പക്ഷേ യൂണിവേഴ്സിറ്റിയിൽ പ്രോബ്ലംസ് ആയിട്ട് ചോദിച്ചിട്ടുണ്ട്, കുറേ പ്രശ്നം ചോദിച്ചിട്ടുണ്ട് ഇതുപോലെ സ്ട്രക്ചറൽ കറം. ഞാനിത് ജനറലായിട്ട് ഞാനിപ്പോൾ ആക്ച്വലി ഡിഫൈൻ ചെയ്തിട്ടുണ്ട്. ഇപ്പോൾ ജനറലായിട്ട് ഞാനിത് എക്സ്പ്ലെയിൻ ചെയ്തു അല്ലേ? പക്ഷേ എക്സാമിൽ ഞാൻ ഒരു 3-4 ക്വസ്റ്റ്യൻ പേപ്പർ ഇങ്ങനെ കണ്ടു, നമ്പറായിട്ട് തന്നത്. ഇപ്പോൾ ഞാനിപ്പോൾ ജനറലായിട്ട് തന്നതിന് നമ്പറായിട്ട് തന്നു. ഓക്കെ അല്ലേ? നമ്പറായിട്ട് തന്നിട്ട് സെയിം ചോദ്യം തന്നെ ചോദിക്കും. ലൈക്ക് ഇതിൻ്റെ മൊത്തത്തിൻ്റെ പീരിയഡ് എന്താ, ഇതിൻ്റെ മൊത്തത്തിൻ്റെ പീരിയഡ് മീൻസ് ഫണ്ടമെൻ്റൽ പീരിയഡ് എന്താ, ഇത് പീരിയാഡിക് ആണോ, പീരിയാഡിക് ആണോ എന്നൊക്കെ ചോദിക്കും. ഓക്കെ അല്ലേ? സോ ദിസ് ഇസ് ദ ഐഡിയ ബിഹൈൻഡ് ഇറ്റ്. ഓക്കെ അല്ലേ? സംശയം ഉണ്ടെങ്കിൽ, സംശയം വരും, ഉറപ്പായിട്ട് വരാതിരിക്കാൻ പറ്റുള്ള സിഗ്നൽസ് ആൻഡ് സിസ്റ്റംസ് ആണേ. അപ്പോൾ സംശയങ്ങൾ പറഞ്ഞു. സംശയം വന്ന ആളെ please post it personal in my personal WhatsApp ID, or else you can post it in the group also, no problem. ഗ്രൂപ്പിൽ പോസ്റ്റ് ചെയ്യുന്നതാണ് എനിക്ക് ഇഷ്ടം, ബിക്കോസ് നമ്മൾ കുറച്ചൊക്കെ വളരും അല്ലേ, കുറച്ചൊക്കെ മുമ്പോട്ട് പോകും. പറ്റില്ലെങ്കിൽ കുറച്ച് പേടി കുറച്ച് പ്രശ്നം ഉണ്ടെങ്കിൽ നോ പ്രോബ്ലം, യു ക്യാൻ പോസ്റ്റ് ഇറ്റ് ഇൻ മൈ പേഴ്സണൽ വാട്സപ്പ് ID. താങ്ക് യു.